Hello and welcome back to Web Components Remote Conf. I'm still Justin Ribeiro. The wind is a little bit more quiet, and we're in our last session of the day. So with us now, Rob Dodson. Rob, how's it going?
Good. How are you?
Yeah, surviving. And rocking the Web Components Remote Conf. Leon, I know you're out there. I see you waving. No, I don't really see Leon waving. I know he's there in spirit. So I'm going to get out of the way, and Rob is going to talk to us today about German airports and accessible web components. Rob, take it away.
All right, thank you. Switch to my slides. All right. I'm going to assume that this is working. I'm going to cross my fingers and hope that everyone can see this. My name's Rob. I'm going to be talking briefly today about German airport and kind of what it taught me about the importance of factoring accessibility into your process early and how web components can help with that. So as I said before, my name is Rob. I'll be your captain today. And I want to start off by telling you the story about Brandenburg Airport in Berlin. So back in 2006, there were some politicians who got together and they said, hey, Berlin is becoming a major business and tourist destination. And it'd be a good idea for us to modernize our airports. They have a few airports over there, but they're getting kind of like long in the tooth. So they said, hey, how about we build a new one to really show off the amazingness of our city? And the plan was to build this new airport and launch it in 2012. And in one night, just take all the traffic from the main airport, Tegel in Berlin, and sort of move it over to this other one. And so they started work in 2006. When they were a few months away from opening the airport, they said, hey, maybe we should do a test of our fire safety system. And when they simulated a fire, what they found was the system went basically completely haywire. Some alarms failed to activate. Others indicated that there was a fire, but in the wrong part of the terminal. The fire doors malfunctioned, they wouldn't open. And the system designed to pull the clean air or pull the smoke out and replace it with clean air actually did neither of those things, and they were worried it was going to implode. And this was a huge problem because back in 1996 there had been a big fire at the Dusseldorf airport that had killed 17 people, and so this wasn't something that they could just gloss over or whatever. It was top of mind for the constituents. And the real problem with the airport lay in the sort of 55 miles of electrical cabling that they had laid sort of hastily underneath the airport. And the problem with that is they're months away from opening the airport. It's not like you can just go and dig up 55 miles of cable and lay it all over again. And so the plan that the builders came up with to try and remedy this situation was they would hire 800 low-paid workers and give them all cell phones. And then these workers would be stationed throughout the airport. And if they happened to see some smoke, they would call like central dispatch or whoever on their cell phone and just let them know that, hey, the airport is on fire. Needless to say, the airport did not receive its operating license. And in fact, I went and I checked recently as I was doing this talk, because I was like, surely this airport is open by now. And in January, like the January that just happened, they found even more issues with the fire alarm system. And so now it's been delayed opening until 2018. Started in 2006, wanted to open in 2012. It's now delayed till 2018. Interesting story. Why am I telling you this? Well, this story was sent to me by my buddy Alice Boxhall. And when she sent it to me, she's like, this is really funny because this is like the perfect analogy for how we deal with accessibility on the web. It's usually only at the end of a project, like after something has launched into production and people are finally interacting with it. It's only at that point that a lot of teams actually start thinking about accessibility, often based on a user complaint or something like that. But at that point, they're in kind of a retrofitting mode, right? They're, just like the airport demonstrated, they're in a situation where they've got to now dig up 55 miles of cable and try and figure out what the deal is. And as that example demonstrates, it's a lot harder to go back and sort of shoehorn in fixes versus doing that work right the first time. So why is it then that businesses tend to ignore accessibility? Because there are these obvious pitfalls to ignoring it. I found this really interesting study. I linked to the article down here in the bottom right. But basically, they went out and they talked to a few different businesses, and they were like, hey, why do you ignore accessibility in your product, or why are you sort of like hesitant or slow to add accessibility to your products? And these businesses said things like, well, we're worried it'll increase the cost of the technology, or it'll lengthen the time it takes to actually develop the product. We might have to sort of sacrifice our aesthetics. We might end up with something that doesn't look cool, right? Or it's just going to be too hard to support all these different users, and so we're not even going to try. It's funny if you look at this list and if you've done any accessibility work, because you know that really there's no reason why any of those things should come true if you're putting accessibility early in your process and you're planning on it and you're making it a thoughtful piece of your design. The irony is, if you build an entire project, if you build your, like that German airport, and you launch the thing into production and you didn't think about some of these issues, then there's a good chance some of the items on this list actually will come true. You very likely will lengthen the time of your development if you're trying to shoehorn in accessibility after the fact. But ultimately, I do sort of understand where these businesses are coming from, because if you don't know much about the topic of accessibility, it's just kind of an unknown, right? And it's very hard to quantify the costs and the time involved in an unknown. And so I think this is interesting, because when we're talking about components, I see this as an opportunity for us, because it's a lot easier to, instead of saying, hey, let's make the whole site accessible, it's a lot easier just to say, let's make a component accessible, right? And then from there, you've now got sort of a foothold. You can start to scope your work, and you can say, all right, we're going to build accessible components. And since this is an audience of folks who are kind of like into the idea of building apps out of components, we know that you build accessible components, you start to bolt those together to build up toward your entire app. And eventually you get to a point where you've got a component that you've built in isolation, it's accessible, you integrate it into your app, you can kind of then audit the experience on the page and then make any sort of necessary tweaks, right? And so it becomes just a part of your process of component building. That's really what I'm advocating, and that's what I kind of want to focus on today, is just giving practical advice, stuff that I learned over the past year, for how to build accessible web components. So hopefully I've convinced you of the merits of this, at least the perils of not doing it. But you might be wondering, okay, cool, like, sounds good, I'm bought in, but how do I go about doing this? And when I was getting into accessibility, the thing that I really didn't want to do was spend a bunch of time like guessing to try and figure out like if I'm doing the right thing or not. If you've tried just like diving into the ARIA specs or something like that, they can be pretty vast and overwhelming. And eventually I landed on this resource that I want to share with you, which has been incredibly helpful for me. And that is the ARIA Authoring Practices Guide. I got a little bit.ly link down there so you can check out. And so the reason why I love this document, and this is version 1.1, this is the latest version. And the reason why I love this document is because it breaks down just about any UI pattern you could possibly think of. So over there on the left-hand sidebar, it says like, alert, breadcrumb, checkbox, whatever. So any pattern you could think of is probably in here. And then it just tells you exactly what kind of keyboard and semantic support you need to add into these elements. So for example, looking at the radio group example, it'll tell me exactly the kind of keyboard interactions that I need to support, how focus should move around the page. And it'll also tell you down towards the bottom, the ARIA roles and states and properties that you need to apply and when you need to apply them. So this is effectively your cheat sheet. If you only take one thing from my talk, please make it be this document, because it's super, super, super useful. And if you build components, you build a component library or whatever, make sure you're integrating this into your process. And not only will it make your components accessible, frankly, it'll just help you build better components, because you'll be sort of thinking about keyboard interaction, which I think Jan had mentioned this before, but like your power users, like me, when I use a form or something, when I'm like buying an airplane ticket, I tab through that thing. I use up down arrow keys. I don't want to touch my mouse if I can avoid it, right? You get extra hacker points for not touching your mouse. So making sure that your components have great keyboard support is just going to benefit really everybody. Another great resource, as Jan was sort of talking about it before, is Jan's gold standard checklist for web components. It doesn't have the same sort of like, it's not focused on like individual UI patterns like the ARIA Authoring Practices Guide, but instead it's meant to present more of like a holistic overview of how you should think about building components. And as you dive into each sort of section, it'll have these specific call outs where it sort of highlights accessibility issues and things that you need to keep in mind. So making sure that you've got proper labels for your elements so that they generate an accessible name. So these are both great resources for you to dive into when you're first getting into accessibility. Inevitably, what's going to happen is you'll start building something, or you'll run into a browser quirk, and you'll end up with some questions. And it's can be tricky to know who to ask these to, right? I think when we think about like web performance or something, names like Paul Lewis and Adi Osmani pop to mind, and you're like, oh, I'll just go find Paul Lewis article. When it comes to like a corner case accessibility issue, it's a lot harder to know where to find good information and who to talk to. So a resource that I found to be really useful is the WebAIM, and WebAIM stands for Web Accessibility in Mind, the WebAIM community, and basically the WebAIM mailing list. So this is a good place to turn because this mailing list is composed of web developer experts and people who actually use assistive technology. And so you can, looking at the checklist, or sorry, looking at the mailing list, I often see questions where people are like, hey, I'm trying to build like a drop down and I'd like it to work this particular way, but I'm not quite sure, is this the right approach? And you'll have people who are actual like screen reader users like pop on and be like, well, when I encounter a drop down, I like for it to work this way. I want it to do this, that, or the other. So this is a great resource because you can get sort of authoritative answers to your questions. So anyway, these are just some good resources to have in your back pocket. I wanted to put them out there early so you could have some of these links. And I figured what'd be cool is to kind of go through the process that I use when I build a component. So I'm going to build just like a simple radio group example. I'm not going to live code it because that'd be crazy, but I'll just like walk through some steps so you can see usually what I do and how I try to implement these accessibility patterns. This is what I want my final markup to look like. You'll notice that there are no ARIA attributes on these elements, and that's because I'm going to have the custom element definitions actually self-apply those attributes. And so this means someone using my component doesn't really need to know about the implementation detail of ARIA. They can just use the component out of the box, and the component will kind of do the right thing. This is something that I personally like. Like, I don't want users to have to sprinkle a bunch of attributes or wonder what those attributes are doing on a component. I want them to just sort of be able to take it off the shelf, start using it, and it just happens to be authored really well and does the right thing. So to start, anytime I'm building anything, I always go to the ARIA authoring practices guide. And in this case, I'll go to the radio group section. And first thing I do is I always start with my keyboard support because it usually basically leads into how I'm going to manage state, and that's usually where ARIA roles and properties things start to show up. So I usually start with my keyboard interactions. And what it says here is for radio group, when the radio group receives focus, if there's a radio button that's already checked, we want to move focus to that checked button. If none of the radio buttons are checked, we should just set focus on the very first button in the group. Spacebar should check a button. And then the right and the down arrow keys should move through the buttons. And as they move down, they should focus and check whichever button they are currently moving down to. Left and up arrow goes the other direction. Again, it focuses and it checks whichever button you're moving to. And whenever you hit the end of the list, you wrap around, right? So if you're on the last button and you hit down, you wrap around to the first button, vice versa, right? Notice, though, that there's no mention of the tab key in these keyboard interactions. And that's because it doesn't want you to tab through every single potentially focusable child inside of a radio group. And this is an important sort of pattern or design pattern to keep in mind. The entire control, if you have a control with like a bunch of children and stuff, you usually want the entire interactive control to be a single tab stop. And the reason is because, you can imagine a user who is maybe motor impaired, maybe they use a switch device or something like that, or it's just maybe someone is a keyboard user, but maybe they have like RSI, they have repetitive stress injury like carpal tunnel. So it could be painful or difficult for those users to hit the tab key a bunch. You want to make them as efficient as possible. And so if you have a control that has a ton of children, think like a country picker, right? So something where it has a ton of children, you don't want someone to have to tab through every single one of those children. You want them to tab to the control, and if they don't want to interact with it, they can tab out of the control. If they do want to interact with it, they can just hit the up and down arrow keys. So that's the pattern that we want to stick to here. And there's really like two techniques for doing this. The first is called roving tab index, and the other is using ARIA active descendant. And I'm going to talk about ARIA more a little later, just to give sort of a general understanding of what ARIA is and how it works. But because ARIA active descendant is related to keyboard stuff, I'm going to talk about it, that one piece right here at the beginning, just so you can understand it. But let me start with roving tab index, just so you can see how that works. So the idea with roving tab index, as I mentioned before, is you only want whatever is the currently active child to be focused. So in this example, I'm building like a fake list box here, and I'm just using divs to illustrate it. But notice that only the second item there has sort of the blue focus ring around it. And again, imagine this has like 100 children inside of it. We only want to ever interact with one child at a time. We don't want to interact with like all 100 of them. So what we do is we set the currently active child to tab index 0. And what that's going to do is that's going to put that child into the natural tab order. So if the user hits the tab key on their keyboard, they can reach the item and they'll get the blue focus ring. We'll set the other children to tab index -1. And so that means they are not in natural tab order, so you can't tab to those, but you can still programmatically focus them by calling their focus method if you need to. Then we're going to listen for, sort of probably at the list box element or the parent element, we'll listen for keyboard events. So when the user hits the down arrow key, we're just going to take the next child, set it to tab index 0, we'll call its focus method, and then we'll make sure all the previous children are tab index -1. So now you can see we've directed focus down to that third item. And this means that if someone tabs out of the control and then they hit shift tab to come back, focus is going to land back on this third item, right? And that fulfills one of the requirements of the ARIA authoring practices guide, where it says, hey, make sure if someone leaves your control and comes back, that the previously active child is the one that focus lands on. So you kind of get that for free based on using this technique. Plus, as we're directing focus to these new elements, they will be announced by the screen reader, which is really nice. So that's roving tab index, very handy pattern. The alternative to that is to use ARIA active descendant. So same example. This time, though, notice that I have not placed tab indexes on any of the children. Instead, I just have one tab index on like the parent element, this big list box. So you can see the blue focus ring is around the entire control, instead of giving all the children an ID, right? And I use ARIA active descendant to point to the child that is currently active. So we're not actually moving browser focus, but we are moving screen reader focus, which is sort of a related concept. And so what we're doing here is, again, still at that parent component level, we just listen for when the user hits the up or down arrow keys. And in this case, when they hit the down arrow key, we just update whichever one is the active descendant. So we now have item 3 is the active descendant. Screen reader will announce that. And we can use CSS to style that child to indicate, hey, this is the one that's currently active. So either of these approaches really works well. It's sort of up to you which you prefer using. There are pros and cons to each. So roving tab index tends to have a bit better support across different browsers. Sort of, you got to think about the kind of combination of operating system, browser, and assistive technology being used. So when you combine all those three things, tab index tends to have a bit better support just because it's been around a lot longer. ARIA active descendant, though, is sort of nice because you don't have to twiddle tab index attributes on a bunch of children. You can just change like one item up there at the top. But it does require you create IDs for all of your children. So which approach you prefer is really up to you, but I'd say make sure you're testing it on different screen reader and browser combinations just to make sure everything is working as expected. The other thing to keep in mind is that with ARIA active descendant, since we're talking about web components, it's important to point out IDs are always scoped to a shadow root. And so if you're building something with several layers of shadow roots, you just got to make sure that you're not trying to refer to something that's across a shadow boundary, because then you'll have issues and it probably won't work. So be careful as you're doing something like that. Okay, back to the radio button example. Let me actually start building this thing. So what I'm going to do is first just define a class for a radio button, and I'm just going to be using vanilla custom elements for this. I'm not actually even going to use Shadow DOM. I'll just use regular custom elements. And so typically what I do is I'll create a radio button, and in its connected callback, I'm going to have every single radio button self-apply a tab index of -1. So this is kind of like setting us up to do that roving tab index effect. In my radio group, I'm then going to just find the first radio button child when I boot up, and I'm going to set that first radio button to tab index 0. So that way, when someone hits the tab key and they move into our group, focus lands on that very first child. And then here's my markup, and this is sort of what's going to be generated based off of those definitions. And so the steps that I want to follow are, one, I want to kind of build up an array, like a collection of all my radio button children. I then want to have an index that indicates which child is currently the active one. And then I'll just be incrementing that index and calling focus. So you can see here, I've like incremented it. So I've moved down to the second child now. So call focus on that, make sure the previous children are tab index -1. And then maybe I'd like set an attribute like checked or something like that to indicate that this thing was checked, and I could style it with some CSS. So this is the approach that I originally used when I first built this radio group. And I like the approach, but if you notice here, I'm keeping track of a couple pieces of internal state. I've got this array of children, that radios array, and I've got this index, right? And sort of every instance of my Dash radio group has to track those pieces of state. And so I actually did this for the show that I do on YouTube called Alleycast. I built this version of the pattern, and you can go and you can see the entire source code for that. And I was pretty pleased with it, but I started to think about those pieces of internal state, and it started to kind of gnaw at my mind that those were there, because I was wondering well, what happens if someone calls a pen child and they just insert a new radio button into the group? What do I do then? And I kind of noodled on this for a bit. And I was like, well, I guess I'll need to create a mutation observer, and I'll watch for changes on my children. And anytime someone inserts or removes a child, I'll rebuild my array of radio buttons. And then I also got to make sure to update my index, because now I've got a different length. And what if they removed the thing that was currently checked? What do I do then? And I didn't like where this line of thinking was going, because I was concerned that I was going to end up writing a bunch of change detection code that ultimately would probably lead to bugs in my component, right? And a lot of sort of weird edge cases and stuff like that. And so as I was poking around, I kind of was looking at other radio group examples, and I was digging through older versions of the ARIA authoring practices guide. And I noticed an example they had there where they had built some stateless controls. And I was like, could I make the radio group completely stateless and then not have to worry about sort of children change detection at all? So this is kind of an experimental approach that I did for that, which I'm pleased with the results, but I'm also kind of curious for other people to try this and see, if this works for them or if it breaks down in certain situations. But basically what I ended up doing with my radio group is I started creating getters for the children, right? So when I'm looking for the currently checked radio button, instead of maintaining an array and maintaining an index, if I ask for the checked radio button, I query for it every time. When I want the first radio button, I query for it every time. And the last radio button, I query for it every time. So basically, anytime I'm doing anything in my component, I'm querying for stuff. Then in my radio group, when I want to say, hey, set the next button to checked, right? When someone hits the down arrow key, what I'm going to do is I'm actually going to say, all right, what is the currently checked radio button, right? I query for that. If it's the last radio button, and again, I'm querying for the last radio button, then let's set check to the first radio button, and we've queried for that. Otherwise, then we're going to set check to whichever the next radio button is. And I pass it a node, and this next radio button method just returns me the next element sibling of that node that happens to be a radio button. All this ends up eventually in this set check method where I've got a node, I'm ready to check it. And so what I do is I loop through all the previous radio buttons, I set all their tab index to -1, and I remove their checked attributes. I take that passed in node, I give it a checked attribute, and I set it to tab index 0. And finally, I just call focus on that passed in node. So I'm just doing the roving tab index approach there, but I'm not maintaining any state to do that. And so what you end up with is something that looks like this. So there's a little video, I'll try and run it. So you'll see initially, right, that our setup is tab index 0 on the first element and then -1 on the children. As we go and we start interacting with this control and we start hitting down and up, we'll see that roving tab index pattern playing out. And the cool thing about this is because we built this as a stateless component, if we just insert another radio button or remove another radio button, none of our code has to change. It's all just going to continue working, which I think is pretty neat. The thing that I was a little concerned about initially was that there would be like a performance hit for this. So I went and I profiled this control. And over in Chrome DevTools, I looked at it, and it looks like it takes for me to hit the up and down arrow key, it takes about 3 milliseconds to ship that frame. So you can see that sort of highlighted up here. Now, if you follow some of the folks on my team, they've got a model that they like to espouse for performance, for measuring performance in your application called RAIL. The R in RAIL stands for response, and generally we say you've got about 100 milliseconds to do a response to a user action. So being able to ship the frame in 3 milliseconds seems like we are well within that budget. So even though I'm querying the DOM in a few places, I actually really like this approach, and it avoids needing to add any change detection code. The one thing that did sort of like bum me out a little bit is calling focus. You'll notice these sort of like purple rectangles down here with the red corners. Those indicate that there's layout being done on the page, sort of like forced layout. And that's because when you call focus, it triggers a recalc style and it triggers layout. So there's a little bit of forced layout that happens as a result of the roving tab index pattern, which is kind of a bummer. But as you see here, it doesn't seem to greatly affect our performance. However, if you were building a really complex control that had a very elaborate DOM, think something like a grid or a really deeply nested tree view or something, these layouts, if you're using roving tab index, might start to pose a performance problem. I'm not sure if they would. You would want to measure that, but that's just something to keep in mind if you're using roving tab index. Just to show you an example, I did the same thing using ARIA active descendant. So in this video, you can see the outline is totally wonky because it's over the entire control instead of the children. But if you look up there, I'm using ARIA active descendant now to indicate which child is active. And if I measure this in Chrome DevTools, the performance is basically the same, like 2.4 milliseconds, like, oh, whoops, let's go back, 2 to 3 milliseconds. Go back. There we go. Oh my gosh. Oh my gosh. We're going totally sideways now. Hold on. This is why you don't put videos in a keynote presentation, because it just like makes your laptop die. All right, let's see. Let's be patient. Yeah, that's the video. That's active descendant. There we go. Okay. So this is the profile for active descendant. You can see, again, we're shipping the frame in around the same amount of time, but there's no forced layout this time. So again, keep that in mind if you're building something and you start to notice like layout possibly being a bottleneck. It could be that roving tab index is maybe not preferable to ARIA active descendant. But as always, tools, not rules. Like measure it and see if that's actually the case. Personally, I'd prefer to use ARIA active descendant if I could. I think it's a little bit nicer than having to twiddle tab index everywhere. But I also don't like creating IDs for every single child. And so I don't know. I go back and forth on that. It also depends on what you're building. If you're building like an autofocus control or an autocomplete control, you kind of need to keep tab index on the text area so the user can type, but you want to do active descendant for the auto completions and stuff. So it also depends on what you're building. All right, so I think at this point we've got some keyboard support for this thing. I skipped over the spacebar, but basically, you know, when someone hits the spacebar, we'd run that set checked method that I showed before. And I think at this point, many developers would probably call it a day. They'd be like, well, I got keyboard support, I got mouse support, this thing is done. But I want to show you what it looks like when we run this using a screen reader. So this black rectangle that you see down here is VoiceOver on Mac. It's the free screen reader. And I don't have the audio playing for this, but you can see the text of what the screen reader is outputting. So I'm going to play this video. And as I interact with this control, you'll see that it just says like water or soda group with 2 items. And you'll also notice that none of the radios are being checked, right? And the reason is because as I'm moving through this, I'm using the VoiceOver shortcut keys to move around the page. And because I've not told the user that this is a radio group, then at no point is the user just going to hit the up and down arrow keys. They're just going to keep hitting the voiceover keys to navigate the page, which is like Control Alt Right. So they're just like scooting through the page using Control Alt Right, and our control is basically being skipped over because a group is just like a generic grouping element, right? It has no idea if we're talking about a div or a span or a paragraph of text, right? Or an actual control. So we're missing these crucial semantics to inform our user that that's what this is. So I want to add those back in, but before I do that, I think it's helpful just to have sort of like a general understanding of like how semantics work in the platform and like really what it means when we talk about semantics and why that's really, really important for web components. Because essentially a web component to a screen reader is a span. And if you don't add anything to it, it will always just be a span. It's just going to say group and then whatever content you have inside of it, which is basically useless to a screen reader user. So when you create native HTML, like an actual native radio button, and you wrap it in a label, the browser is able to generate a visual UI based on that markup. But because you've used these semantically rich elements, it's also able to generate a spoken UI, like this one that you see down here, where it says round trip selected radio button. So that's probably what VoiceOver would announce for something like this. Now, generally speaking, for every HTML element, the browser is able to compute some important accessibility information for it. It's able to compute that element's role, so like checkbox or radio button. It's able to compute that element's name. And when I say name, don't think of like the name attribute for submitting forms. Think of name like a label, right? So it's able to compute its role, its name, or its label. Some elements have states, so like a checkbox with a check state. Not every element does though. And some elements will have a value, like an input text field has a value, but again, not all elements do. But generally speaking, these are the 4 properties that you're looking for to convey meaning to an assistive technology user. And so when we use just like regular native HTML elements, we get all these for free. And that's because they're actually built into the browser. So when the browser is handing off data to the accessibility tree that's going to build in a second, it just tells it all this information based on the tag. But if you're implementing your own version of these elements, right, you're implementing your own checkbox or something using a div or using a custom element, then that information is not going to be conveyed. Sighted users are going to be able to see these visual cues, and they're going to be able to know, oh, hey, that's a checkbox, and I can click on it. But a screen reader user is not going to be given the same affordances because, as I said before, every web component is essentially just a span to a screen reader. And so to fix this, we have the Web Accessibility Initiative's Accessible Rich Internet Applications Spec, or WAIA, or sometimes just referred to as ARIA. And what ARIA does is it basically allows you the ability to specify attributes on elements, which then modify the way that element gets translated into the accessibility tree. So going back to the checkbox example, if I add an ARIA role of checkbox to that div, if I add an ARIA checked attribute and set it to true, now you can see that we've got the properly announcing semantics down there in that bottom right box. So what's actually going on under the hood when you add ARIA and what the browser is actually doing, which I found pretty interesting, was when you write HTML, the browser generates a DOM, and I think we're all familiar with the DOM, right? It's the sort of object model of all your instances on the page. But then from the DOM, it also generates what's called the accessibility tree. And this is a node graph similar to the DOM of all the sort of semantic information about all the nodes in the tree. And some stuff that's unimportant gets skipped over. So sometimes the accessibility tree is a little more sparse than the page. But what's cool about it is using ARIA, we can basically do surgery on the accessibility tree. And we can modify it, and we can make it subtly different or radically different depending on the attributes that we use. The thing to keep in mind, though, is that the accessibility tree is really the only thing that ARIA affects. So ARIA does not change the appearance of an element. It does not change the behavior. It doesn't magically make things like work with the keyboard. At one point, I used to think, if you just had the right combination of ARIA attributes, like my fake button would suddenly be like, clickable and understandable by a screen reader, or they could interact with it. It would add all this keyboard support, right? That's really, really not the case. The only thing ARIA does is add semantics to an element. So what is expressed to a screen reader or a Braille reader It's not going to magically add keyboard focus. And that's very important to understand. So as we saw in the checkbox example, you can use ARIA to add semantics to a control, which is very cool and very useful. But there's other things that we can do with it as well. We can add labeling to controls, which otherwise would not have labels. So for instance, I've got this filter button up here in the top sort of center of the screen. And normally, for some UI, you just don't have a place to put text on screen. Another example is like the classic hamburger menu button on responsive websites. So people usually don't put any text near those buttons. And so when a screen reader lands on it, it just says button. And it's like, okay, well, what does this button do? Does it send you my social security number? Like, what is this button? So using ARIA label, we can actually add some semantic information to that. We can give that element a label that way. And now we don't have to display the text on screen, but it's still conveyed to a screen reader user, which is really helpful. You can also use ARIA to create really interesting relationships that go beyond sort of the standard DOM, parent, child, sibling relationships. So an example would be an element where you say, hey, this element controls that other element over there somewhere way else on the page, which is a really, really useful thing to have for disclosure widgets and things like that. You can also use ARIA. You can use roles or ARIA live regions to indicate that a section of the page should be live, meaning anytime you put text in it or update the text in it, it will immediately be announced by a screen reader. So this is good if you need to alert the user to something. You could say, hey, couldn't connect to this page. Or if you have in-page notifications or little toasts that pop up and stuff, you can drop that into a live region and the screen reader will sort of interrupt whatever it's currently doing and announce that to the user, which can be very helpful. But the reason why I really wanted to talk about ARIA today was because it allows you to express UI patterns, which otherwise are not possible using native HTML alone. So this is where I think it really kind of comes into its own and where it's really interesting for web component authors. It basically allows us to just create these widgets that aren't possible with native tags. So we can start building a web component, we can add in these new semantics, and now we've got something that is just as good as the native built-in elements, and it wasn't possible before. So let's revisit the radio group then and add in that semantic information to make sure it works well for screen reader users. Again, to figure out what I need to add, I go back to the ARIA authoring practices guide and I look at the radio button section and it tells me right here up at the top, the roles, the states and properties that I need. So I need to make sure I have role of radio group on the outer control and role of radio on the actual inner buttons. And then when any of those buttons are checked, I need to toggle their ARIA checked states to true or false. And then I also need to apply labeling of some kind. So let's go through that. Let's look back. So this is sort of like the constructor I originally had, or the connected callback for my radio button that I originally had, where I was doing roving tab index, so I was just setting it to tab index -1. The one addition, or the two additions that I'll make to this is I'll also have the element self-apply a role of radio and self-apply an initial state of ARIA checked being false. And for my radio group, similarly, I'm going to self-apply a role of radio group. And then the other thing that I did here, and again, this is sort of experimental because I'm trying to still figure out some of the best practices for accessible web components. But the other thing I wanted to do was, rather than querying a child based on it being a dash radio button or querying it based on the tag name, I decided to query the children based on the role that's being expressed. So if the child is upgraded properly and it's expressing the radio role, then I select it and set its tab index to 0. Similarly, I was showing the set checked method before. And again, this walks through my radio group. It unchecks all the previous buttons and then it sets the currently passed in one to checked. And so diving into this a little bit more, if you look at this uncheck all method, I'm looping through all of my radio buttons and then I set them all to tab index -1 because I'm unchecking them for the roving tab index pattern. But then I also make sure to set their ARIA check state to false. And similarly, when I check a button, I set its tab index to 0, but I also set its ARIA check state to true. And so what this ends up producing is something that looks like this. So it's self-applied all of these attributes over here in the element inspector that you see. And as I walk through this with my screen reader, it's going to tell the user, hey, you're on coffee, and it's a selected radio button. And in fact, the first button they land on says, hey, it's a radio button. So now my user has an indication that they should use the up and down arrow keys to interact with this control. There we go. Now, kind of going on a bit of a aggressive enhancement tangent for a sec, one question that I've been debating with some friends is like, well, why not send down the element with the roles already applied? So for instance, why don't I write my HTML like this, right, with the roles already there? Why do I wait for the custom element to self-apply these things? And my thinking here is if I send down an element with these roles already applied and JavaScript fails to load, then that element's going to say it's a radio group or say it's a radio button, but it's not actually going to work. And so one idea that I've been thinking is, what if we send down more primitive roles, and then when the element upgrades, it replaces those roles with the more advanced widget roles. So for instance, initially a radio group is just kind of like a bunch of list items. And then only when it upgrades and sort of been imbued with the power of JavaScript is it now suddenly a radio group with actual radios inside of it, right? So this is an idea that I've been kicking around. It applies to, you know, like tab lists, right? So say you've got a bunch of clickable tabs, and if you think about it, if your JavaScript doesn't load, you want that tab list to sort of degrade into being just like headers and sections. And so you can do that with the roles model as well. You could just initially send down your tabs list as like role header, role section, and once it's imbued with JavaScript, it becomes role tab list, role tab panel, stuff like that. So just an idea that I've been kind of kicking around. Bit of a progressive enhancement tangent there, but I'm curious what other people think. To wrap up, I just want to talk a bit about the future and where I see some of these things heading. One project that I'm really excited about and interested to see move forward is Jan's Elix project that he was talking about earlier. So Jan showed the selection ARIA Mixin class. The reason why I think this is so interesting is because, you know, I think there's a lot of folks out there who they want to make sure that they're building accessible components, but maybe they're not an accessibility expert, and maybe they're not one yet. And the nice thing about these mixins is you don't have to be an expert to make sure you're doing the right thing. They sort of give you a blueprint that you can mix into a component, and then you can, so long as you comply with a particular interface, this mixin will just, you know, do the right things for you. It'll apply the right ARIA states. It'll apply the right ARIA roles on your behalf. So this is an example from the documentation of the single selection mixin, or the selection ARIA mixin for Elix. And you can see here that it's pretty straightforward. Like, you're just sort of composing these mixins on HTML element. There's an interface that you need to comply with. But the cool thing about this is it lets you write markup that looks like this, right? So this is a sample list box. The only thing that Jan had to do here was put an ARIA label on it. So when you land on the control itself, it announces what it is. But otherwise, if you look at all these divs, they don't have any ARIA on them whatsoever. The outer element doesn't have, you know, active descendant or anything like that. When you go and actually use this, you can see over there in the DevTools element inspector that as soon as the elements upgrade, now they've got tab index, now they've got the right roles, they've got auto-generated IDs. And as the user is arrow keying through this experience, it's going to tell them like, hey, you're on apple number 3 of 43 of this list box. And again, that's all based on using the right ARIA attributes. And you're getting that all for free, which I think is really, really awesome. So if you're interested in this, I'd encourage you to go check out Jan's Elix project at elix.org. You know, maybe help out with the RFC process, help write some mixins, and maybe see if we can like move this forward, because I think it's just a neat idea. To close, I want to leave you with this quote. You can tell this to your business person or your project manager next time you're like, I want to work on accessibility. And they're like, nah, maybe later. So this is from Cordelia Dillon, who works at Dropbox. And she said, accessibility is like a blueberry muffin. You can't push the berries in there afterward. And it's so true. Whether you're building like an airport in Germany or you're creating the next great web startup, you got to remember that like as an engineer, it's really your job to do the upfront work to ensure your project is successful. And so on the web, we've got an obligation to offer equal access to all of our users. And as web component authors, we're in this really unique position because it means we can sort of seed the ecosystem with accessible components that make the next generation of web apps just much easier for everyone to use. If you're interested in the topic, I'd ask that you check out our docs over at Web Fundamentals. So it's bit.ly/A11Y-fundamentals. I maintain and manage this set of documentation. I want this to be like a living doc set. So I've got plans to add a bunch more to it. And the main thing that I want to have here is sort of like really pragmatic, really practical advice for developers. who are building modern web apps. So if you're building a progressive web app or you're building for the mobile web, like what are the accessibility things that you got to keep in mind? So definitely go check that out. That is my time. So thank you all so much for listening.
Switching things. Boom, boom. Thank you so much, Rob.
Yeah, thank you. I'm glad that it worked. I was so nervous that I was like, I bet I'm doing this talk and like they're frantically IMing me on Slack, being like, it's not working. But
we already did that. We already did that to Danny this morning. So
okay, so I'm glad you got it worked out.
We got a question from the audience. The question is from Noah, and Noah asks, is it a good strategy to back custom controls with native elements for their accessibility affordances? For example, creating a custom radio group component in which a screen reader user interacts with a native radio group while other users interact with a custom styled component.
Yeah, that is a good question. So it varies, I think. In general, I try to encourage people to use the native elements wherever they can. So a good example is something like the button element. So button, there's really like no reason to implement your own button, right? Because the button element has built-in semantics, it's very easy to style, and it just kind of works and does the right thing. Where it gets a little bit trickier is with something like select, like we talked about before, because select is actually a very powerful component and has a lot of things that it does. So if you're confident in your ability to go through and do like all the right ARIA and make sure you're adding all the right keyboard support and all the right usability steps, you could endeavor to build your own select. It may just be a lot easier though to back it with the native element and apply kind of like a styling layer over the front. And that's what, there's a good site, what is it? I think it's called WTF Forms. I think it's, I'm pasting it in the chat. I can't remember if it's like 1F or 2Fs, but that's made by Mark Otto, the guy who did Bootstrap. And it's basically examples of taking all the native controls, and he just uses like divs to do it, but taking all the native controls and basically putting like a layer in front of it. And now you can style them, because the big drawback with all the controls is that they're hard to style. So select and checkbox are a pain in the butt to style. That's one of the only reasons why I'd ever do those as custom elements. But yeah, if you can back it with the native one, that's probably going to be easier for you.
So a question comes in from Danny. Oh, hi, Danny. Are there automated tools to help out with this ability? There are a few out there, yes?
Yes. So I actually have I have this show called Alleycast that we do on YouTube, and I have an episode coming up in 2 weeks, or at some point, 2 to 4 weeks from now, where I go through one of my favorite controls, or one of my favorite tools right now, which is called Axe. Yeah, there we go. Brian Bell got it. So yeah, Axe is awesome. So it's made by DQ Systems. Marcy Sutton, who some folks may have heard of, works on it, along with Dylan Barrel and some other cool folks. Axe comes in a few different flavors. So there's Axe Core, which is the actual sort of little testing engine. And then it's been sort of like packaged up into different modalities. So you can use it as a Chrome extension. You can use it as a CLI. You can just run it from the command line. Or they have like a Selenium driver, like sort of plugin thing that you can use, so you can add it to like your automated testing. The main thing to know about Axe is that right now Axe does not have support for Shadow DOM, but CSUN, the big accessibility conference, is coming up at the beginning of March. So I'm going to be there. Alice Boxhall is going to be there. Marcy Sutton's going to be there, and we are planning to do like a hack day to try and add Shadow DOM support to Axe. So look forward to that. So anyway, Axe is a good one. The other good one is the Chrome Accessibility Dev Tools by Alice Boxhall. Very similar to Axe. It'll just sort of like audit your page and tell you where you've got errors. The nice thing is, I want to say Alice's thing does support Shadow DOM, but I'd have to double check on that. And then we're actually building DevTools in Chrome. So if you enable experiments in Chrome, so you go to like Chrome flags, enable DevTools experiments, there is new accessibility dev tools there that Alice is building that will be coming out soon.
Well, fantastic. Thank you again so much for taking time, Rob, and
Yeah,
being
thanks for having me.
at a conference with a great accessibility talk. For you of those out there watching the live stream, we're gonna wrap up this session. We'll wrap up the entire conference in just a sec. So stick with us.